Lesson 7.1, Triangle Inequality Theorem Review. So if you remember, the sum of the lengths of any two sides of a triangle is greater than the length of the third side. That must be true. We're going to apply this to right triangles in a moment, but let's review this for a moment first. Again, the sum of any two sides must be greater than the third side for it to work. And we can do inequalities here to decide this. So what is the range here? So if we go through the ranges, we have 4 plus s must be greater than 7. 7 plus s must be greater than 4. And 4 plus 7 must be greater than s. If we solve these, for the first one, if I add or subtract 4 from both sides, I get s must be greater than 3. On this one, if I subtract 7 from both sides, I say s must be greater than negative 3. And then on this one, add them together, we get s. And I'm going to keep the inequality but redirect this. Well, maybe I shouldn't do that. I'll just keep the same order here. And we have 11 is greater than s. Now if you remember, we cannot have a negative distance, so we'll ignore that one. We have a small value of 3 and a large value of 11, and our s must be between those two. So this is the range of values that would make this triangle work. So the next one here, given an isosceles triangle with base length 13, what is the smallest possible integer length of the legs? So if we draw that out, isosceles triangle with base length 13. Remember, we do not know these two lengths, but we do know that they are the same because it's isosceles. Now we would go through the same process. A plus A must be greater than 13. A plus 13 must be greater than A. And 13 plus A, the other side, must be greater than A. So the first one gives us 2A greater than 13, which is, if I divide both sides by 2, 6.5. And this one here, if I subtract the a from both sides, I get 13 is greater than 0, which is true, but the variable is lost. And the next one, same thing. But there is no variable. So those are out. So the smallest, so A must be greater than 6.5. So the smallest possible integer length would be 7. Again, 7 because they want an integer, so no decimals. And this ends Lesson 7.1, Triangle Inequality Theorem Review.